This is Algebra 1, Lesson 7.3. We are solving linear systems by using linear combinations, also known as eliminations. We're using linear combinations to solve systems, and then we'll look at some real-life problems beginning on 411. A linear combination is one of two equations, um, is an equation obtained by adding one of the equations for a multiple of one of the equations to the other equations. We are going to combine both equations in a system to eliminate one of the variables. We may have to alter one or both of the equations to do so. Here is example number one. It says solve the linear system. 7x plus 2y is equal to negative 6, and 5x minus 2y is equal to 6. When we combine, I don't want you to think of this, it says using addition on the top. I don't want you to think of this as addition. I've been trying to get you to think of addition and subtraction as the same thing since we began this class. Remember, addition and subtraction are both combining the terms. Addition just happens to be positive and subtraction happens to be negative. When we combine these terms, notice the first thing you need to check, and we'll get to how to fix it if it's not true. But the first thing you need to check is you need to make sure your x's are stacked on top of each other, your y's are stacked on top of each other, and your constants are stacked on top of each other. That is the case for this one. When you combine the two, if we combine 7x and 5x, we get 12x. I'd rather write it a little bit different. 7x plus 2y equals negative 6, and 5x minus 2y equals 6. When you combine these two, 7x and 5x gives you 12x. 2y and negative 2y eliminates that part. And 6 and negative 6 together is 0. So you have an equation now that only has one variable, x. 12x is equal to 0. You know how to get x by itself. You simply divide by 12 on both sides, and that gives you x's value equals 0. So again, remember, with systems, this is not the solution. That is the x value. Remember, it's going to be x comma y. So we need to find now the y value. In order to find the y value, you use the substitution method, which we learned last week, and you plug in 0, or you substitute in 0 for x in the easier or the easiest, if there's more than two, the easiest equation you can find. So if they all look the same, plug it in or sub it into the first equation. If one looks substantially easier, plug it into the one that looks easier. In this case, they plug it back into the first equation. So instead of saying 7 times x, notice it says now 7 times 0 plus 2y equals negative 6. You know anything times 0 eliminates that part of the problem. So you have something that simply says 2y equals negative 6. To get y by itself, you divide by 2. And when you divide negative 6 by 2, you get negative 3. That gives you a y value of negative 3. Remember, you had an x was 0. Now you got a y of negative 3. Remember, it's x comma y, or 0, negative 3. That is the solution using the combination method or the elimination method. Again, it says check 0, negative 3 by plugging it into the original equations. See if you get two true statements. 7 times 0 is 0. 2 times negative 3 is negative 6. 5 times 0 is 0. Negative 2 times negative 3 is positive 6. So that's two true statements. 0, negative 3 is the solution that goes with it. 0, negative 3. On the back, let's do this one. Negative x plus 2y equals negative 8. Use the combination method. And x plus 6y equals negative 16. Take about a minute for that one. Okay, as we look at this system, as we look at each of these equations, your x's are stacked on top of each other. Your y's are stacked on top of each other. Your constants are stacked on top of each other. That's the first thing you need to check. Make sure your columns are straight. Then you want to check and see if you have opposite coefficients. 2 and 6 are absolutely not opposite, so you can't eliminate the y's. But 1 and -1 for your x's are definitely opposites. So when we draw a line underneath it, we can combine -1x and +1x gives us no more x's. I like to draw an underline right there to show that we eliminated. 2y combined with 6y gives us 8y. And -8 combined with -16. Both of them are negative, so add them up and get 24 and keep the common sign negative. Remember, it's not multiplying. You're simply adding -8 and -16. Now you got something that simply says 8y is equal to -24. That we know we can get y by itself by dividing by 8 on both sides. A negative divided by a positive is going to be a negative now, and 24 divided by 8 is 3. Remember, that is not enough. That is simply the y value in our ordered pair, x comma y. That means in place of y, we have a number, -3. Now we need to find x. So take -3 and sub it into either one of the equations that we had. Doesn't matter which one you pick. Pick the one that looks easier. Okay? If they look the same again, plug it into the first one to keep it consistent. So in place of y, -x plus 2 times y is now -3 is equal to -8. 2 times -3 is -6. So -x minus 6 equals -8. Get x by itself by adding 6 to both sides. -x equals -2, since those are opposite signs. Then that doesn't say x, that says -x. So you have -1 times that. Divide by -1. And when you do it to this other side, a negative divided by a negative, we all know is a positive. X then is equal to 2. So your x value is 2 and your y value is -3. So if you graph both of those equations, they will intersect at point 2, -3. Algebraically, you can plug those numbers in. Negative x or -2 plus 2 times 3 times -3 is -6. -2 minus 6 is indeed -8. Positive x or 2 plus 6 times y, 6 times -3, which is -18. 2 minus 18 is, in fact, -16. Therefore, this is the solution to your system of equations. 2, -3. If you have a situation where your x's are on top of your x's, your y's are on top of your y's, and your constants are on top of your constants, but you do not have coefficients that are opposite of each other. Notice we have 3 and 2. Those are not opposite. And we have -5 and +20. That means you need to multiply one of the equations or both of the equations to create opposite coefficients. So look at these two. What is the least common multiple of 3 and 2? What number do they go into the soonest? They go into the number 6. So in order to eliminate the x's, you would want to multiply 3 times whatever you got to multiply it by to get 6, and you would want to multiply 2 times whatever you'd have to multiply it by to get the opposite, which is -6. You could also do the exact same thing with your y coefficients. What is the first number that 5 and 4 go into? 20. So if we wanted to make -5 into -20, we would multiply it by 4. If we wanted to make 4 into +20, we would multiply it by 5. The thing with this, though, when you do have multiplication, is students will multiply just fine to both of the ones that they're eliminating. You can't just multiply by the one term in each equation, though. If you're going to multiply by something, you have to distribute it and multiply by everything in the equation. That being said, it says you can get the coefficients of x to be opposite by multiplying the first equation by 2 and the second equation by -3. So when you multiply this equation by 2, you have to distribute it not only times the one you want to change to 6, but you also have to give it to the -5y and also to the 15. So 2 times 3x is 6x, 2 times -5y is -10y, and 2 times 15 is 30. Again, we're trying to make opposites 6x and -6x. So in order to create -6 on the bottom, we need to multiply it by -3. So -3 times 2x is -6x. -3 times 4y is -12y. And -3 times -1 is +3. So that is distributing 2 to the first equation. Remember, you have to multiply it by all terms in it. And -3 to the second equation, same thing. Now you have two equations here that are stacked on top of each other with opposite coefficients, 6 and -6. That means we can combine them just like we did for example number 1. 6 minus 6, or 6x minus 6x, eliminates that part of the problem. That is the goal when you use the combination method. So you have -22y. When you put -10y and -12y together, -22y. And when you put 30 and 3 together, you get 33. So -22y equals 33. Divide by -22 on both sides. And we know we would get 33 over -22, or -3 over 2, which they which they made it into the decimal equivalent, -1.5. So that's finding the y value. You still need to find the x value. Plug that value in, -1.5 in place of y. Notice it tells you to plug it in to the second equation. It doesn't matter which one you plug it in. The reason they chose the second one is because 2, 4, and -1 looked easier than 3, -5, and 15. But in place of y, we plug in -1.5. So 4 times -1.5 plus 2x is equal to -1. 4 times -1.5 is -6. So 2x minus 6 equals -1. Then undo -6 simply by adding 6 to both sides, and you get 2x equals 5. And then when you divide by 2 on both sides, you get x's value, which is 2.5. So we had y's value -1.5. Now we have x's value 2.5. So your solution is x comma y 2.5 comma -1.5. X comma y. On the back, one more time. Solve the linear system. You want to make opposite coefficients. You want to make 5 and 2 into opposites, or -4 and 8. Take about 1 minute on that one. Do the easier version that you can. So we can make 5 and 2 into the number 10 and negative 10, but it's even easier to make negative 4 and 8 into negative 8 and 8. In order to make this negative 4 into negative 8, we need to multiply this equation by 2. So 2 times 5x is 10x. 2 times negative 4y is negative 8y. And 2 times 3 is 6. Now we have two equations that have opposite coefficients, 8 and negative 8. When you combine these, we get 12x. The y's eliminate, and negative 2 and 6 gives us 4. Divide by 12 on both sides, and we get x's value as 4 over 12, or 1 over 3. Once you have that, plug it back in to get y's value. Use the substitution method.